So far in this unit, we have been learning how to solve linear equations. But what about inequalities? Because yes, we can solve for variables inside of inequalities. We just have to follow the rules. But before we solve for linear inequalities, let's review the signs of inequalities. And for this review, we're going to help ourselves with this number line, including all real numbers from negative infinity to positive infinity. First, we look at this equation, x equals 4. This equation is telling us that x, the only possible solution for x, is 4. So let's locate it in our number line, and that's our solution. That's the only solution. 4 is the only solution for this equation. But what happens if we change this for x greater or equal than 4? We now have a new inequality sign. X greater or equal than 4 means x can be any number greater, bigger, any number that is bigger than 4, and 4 is also included in our solution. So this dashed line represents the possible solutions to this inequality. 4 or any number bigger than 4. For example, 5, 17, 245, 1956, 4.02, 4.32, or 4. All of these numbers are possible solutions to this inequality because all of these numbers are bigger or equal than 4. But what happens if we change the sign? What happens if we now make it x is greater than 4 without the equal sign on the bottom? When x is greater than 4, it means, yes, numbers are still any number bigger than 4, but that means we have to get rid of the 4. 4 is no longer a solution. So let's delete it from our solution set. Any other number greater than 4 is good, but 4 is not part of the solution. Let's change it one more time. Now we have x is smaller than 4. If x is smaller or lesser, which is another word we use, it means we no longer have this solution set. We have to change it to the other side because now our possible answers are numbers that are lesser, smaller than 4. For example, 3, 0, negative 5, negative 342, negative 7.28, 3.9999. Any number that is smaller than 4 is part of our answer, but not 4. 4 is not part of an answer. If we change this to x is smaller or equal than 4, now 4 is back as part of our answer because now we have the little equal sign. So we can put the little dot on the 4. So any number smaller than 4, including 4, is part of our solution. Now, how do we solve for variables inside of inequalities? We actually use the same rules we have been using throughout the entire unit 3. The inverse operation. This is a two-step linear equation, well, a two-step linear inequality, to be more precise, and we know we start with the addition subtraction. So, if we have a negative 3, the inverse operation of a negative 3 is a positive 3. That way, we can cancel them. But the golden rule of algebra also applies for inequality. If we added a 3 on the left side, we also need to add a 3 on the right side. 12 plus 3, that's equal to 15. So x divided by 2 is greater or equal than 15. The next step is that 2 in the division. The inverse operation of a 2 dividing is a 2 multiplying. So the 2's cancel, but if we multiply times 2 the left side, we also have to multiply times 2 the right side. Then we do 15 times 2, and 15 times 2 is 30. So x is greater or equal than 30. What does this represent? Let's use our number line again. 30 is in that number line. First, we take a look at the little line under the sign. This means 30 is included. 30 is part of the answer. So we put the little dot. And then x is on the opened side of the sign, which means x is greater than 30. So any number to the right of 30. So what are some of our possible solutions that we can have? Well, any number that is 30 or greater than 30, like 31, 54, 87, 528, 30.01, or even 30 included. So any number that is 30 or bigger than 30 is part of the solution for this problem. So x is greater or equal than 30. Let's do another example. We know practice helps us to better understand math. 4x plus 7 is smaller than 3. Two-step equation, two-step inequality, linear inequality, meaning we start with the addition subtraction. So we start with the plus 7. What's the inverse operation of a positive 7? It's a negative 7. That way we can cancel. But the golden rule of algebra, if we subtract it by 7 one side, we have to do it on the other. Then we do the operation. 3 minus 7, remember the rules of signs, the 7 is the bigger number, so this is negative 4. Now we can do the multiplication division, which is the 4 is multiplying that x. So we have to do the inverse operation of a 4, multiplying 4, which is the dividing 4. That cancels our 4's, but if we divide it by 4 the left side, we divide by 4 the right side. Minus 4 divided by 4, one more time, rules of signs. When a negative is being divided by a positive, our answer is negative. So x is lesser than negative 1. One more time, let's review our answer. Let's review how do we represent this solution set. We use the number line. X is on the close sign of the side of the sign, meaning x is smaller than negative 1. And if x is smaller than negative 1, means our solutions are to the left of negative 1. We do not include negative 1. We do not see the small equal sign. So let's review some of our possible solutions. We have negative 2, negative 17, negative 102, negative 1.25, negative 1001. And what about negative 1? We just said that inequality sign does not have the little line on the bottom, which means negative 1 is not part of the solution because x is not equal to negative 1. It's just lesser or smaller than negative 1. So we don't include the negative 1 in the solution. So x is any number lesser than negative 1.